All right, so I'll talk a little bit about hinges, really short. There's several types of hinges, and I'm going to upload a few papers on this that were written back in the 90s when they figured out how to make hinges with surface micromachining. So I'm going to encourage you to read those as well so you can understand this better. But here's a staple hinge. We also call it an anchor hinge, this one up here. Okay, so that's a staple hinge. It basically has a staple and then a part that hinges around it, right? You have the post here that goes through the staple. So everybody kind of understands how that works, right? That's pretty straightforward. They're used in flip mirrors. And on the assignment, you'll see a flip mirror device on the cover, and I'll show that in a few minutes. Okay, and then we have sliders. So you can have one piece slide within another piece. And notice they have these ends here to keep the slider from falling out. So you can either put the ends on this part of the slider, or you can attach the part that slides, right, to some post, so it can only go so far, and it won't fall out of the track. Okay? You also have hinges that are flexures. Okay, these are torsional springs. They bend. Okay, that's a type of hinge. That's what the Texas Instruments digital mirror device uses. They have flexures. Okay? And you probably see them in other applications. Can anybody think of one that we see every day? A flexure hinge? A door, that's more of a pin. It has a pin in it. A book, maybe? A bound book that flexes. Your spine?
No, the spine of the book.
Spine of a book? Yeah, that's what I'm talking about. The spine of a book, right? Like this book here. You can see, it doesn't have a pin in it. It's not a slider, but it flexes. Okay? So sometimes a flexure works really well. Here are some examples. Okay, here are some torsional bars. These are flexure hinges here, but then these are more like the pin type and staple hinges here and here. So this would be an anchor hinge. Okay, we're hinging this polycrystalline silicon component here to the base, and then we pop it up. And then here's a hinge that connects two parts together, two polycrystalline parts together. So you see all kinds of hinges in here. So that's why I have you do this assignment, so you can see how to design 3 different kinds of hinges. So this is a vertical scanning mirror, and this is a horizontal scanning mirror. And this was done at University of California, Berkeley. I think it's even in the paper I'm going to post, so you can read about it. Here's a ground hinge. Okay. So this is a Sandia hinge. You can actually find this in the component library. So when you draw your own hinge, go ahead and use the component library. Copy the hinge down into your design and cross-section it and start to learn how it's made. Okay, and then when you draw your own hinge, okay, make something similar to that, you can refer back to how this is done. So this is a scanning electron microscope picture of this type of hinge. All right, so here's the staple. Right, that would be this part from here to here with a poly 3 going across the poly 2 that's anchored. And then this poly 2 plate here is actually this part. And the plate's connected and continues on. Okay, so that's what these 2 hinges are here. All right, and if you go through it step by step, you can see how it's built. Okay, so there's your poly 1, poly 2, it's a laminate, and now you're going to use this mask, okay, to make the hinge elements. Then you make some anchors for the poly 3 structure and pattern and etch that. So you end up with this nice staple here. That's this part. Okay, get used to looking at this and compare it to the actual photograph. Okay? See if you can envision that. This is the hingey part, right? The pin right here. So we're drawing a line across this structure, and looking at it from the side. This is the part that hinges. Notice this is flipped 180 degrees from this picture, unfortunately. Okay, so it's a little confusing. So this is the part that moves up and down, and this is the part that rotates within the staple. Can everybody see that? Does that make sense? You drawn enough that you can